Hello, everyone. Thank you for coming this early to listen to me. I'm Bogdan Amidzic from Crater Studio, and my role went from compositing supervisor effects, and now I'm more like FXTD. And today I'm going to tell you mainly about how to handle large-scale RBD simulations in Solaris. And I'm going to show you one project in which we battle-tested these techniques. And first, I'm going to show you a reel of our studio. This is short version of the reel. Who wants to see bigger? I have a cards with barcode. So we are a team of around 20 to 30 people, depending on projects we scale up. And as you saw, we work on a really diverse range of projects. And we have a couple of teams. One is effects, one is compositing, and one is character team. And we adopted this whole USD pipeline around 2020. So at 2020, we first started some smaller projects, testing it in Houdini 18.5. And our pipeline is not very advanced, but it's constantly evolving, and I'm pretty much involved into that. And as you can see, we like to work hard and also to party hard. Okay. So the project that I'm going to show you today is called Operation Hadal. And it was done in cooperation with EDF Entertainment and Stealthworks. And their supervisor, JC Lin, provided us with chance to get involved in this project. This guy is really like a skilled, experienced ex-Veta effects TD. So these are some of the shots that we did. So we did one sequence above water and one underwater. And today I'm going to show you how we did destruction in this underwater sequence. And for us, this was the heaviest destruction work that we did up to date. Okay. There are a couple of more shots. Yeah, we also did this underwater explosions with negative divergence. Okay. Okay, that's project real. Okay, so many of these things I already said. The main thing that we got assets from client in USD format, and this was coming from not only from Houdini but also from Maya. So the first thing was this like scale issue, for which I just told them, don't be worried about that. Okay, so the asset that we got from client for this big environment piece was like you do it in Unreal. Like you just throw a bunch of assets that are instanced in the scene and don't care about intersections between these, which means whoever does effects on this will be doomed, and that was me. Yeah, so. This is a little bit in detail how this asset looked. So these blue primitives that you see, these are not references, these are instanceable reference, which means that they are very efficient in memory. So you can see them in scene graph, you can move them, and that's it. All the other stuff, it's very complicated to deal with them, but they are memory efficient. And here you see how much intersection there is between these asset pieces. Okay, so I mentioned these instanceable references. So here what you can see is if you reference some asset, this is like a typical Megascan asset. If you copy it, you will see that memory gradually rises. So here I'm going to 200 copies and memory rises. And then at 2000, I'm already taking 40 gigabytes of RAM for like 2000 assets that should be instanced. So how you should load it, you should check it to be instanceable reference. And in scene graph, they will become blue. And now you will see, no matter how many copies of the assets you have, memory stays low. So there is no penalty on the memory. The only penalty is that Solaris takes some time to refresh scene graph. So in this case, for 20,000 copies, it took like 1 minute just to populate scene graph. But after that, everything works fast. And if you use this like paint brush dressing nodes in Solaris, layout lop, everything is instanceable reference by default. Okay. So then how to destroy this? And my first thing was to try to unpack it to polygons. And this is only one part of the asset. So this is what happens when you try to unpack it to polygons. Yep, so dead end. And eventually this happens, yeah. Okay, so we have to rethink our approach how to deal with this. And I had this idea to pre-fracture my prototypes and then instance them back into place. And other approach was to try to somehow merge everything, maybe to get a terabyte of RAM or something like that. So this instancer approach, I'm going to, so these are these asset prototypes. So if you fracture each one of them, okay, and then instance them back into place, you get a lot of intersecting pieces. But let's say we have our RBD pieces, like we fuse, we merge everything into VDB and create our RBD pieces, do our RBD simulation, and then just, let's say, transform these smaller pieces. This idea could work, and you could have like unlimited amount of things. The only thing is like you have to pre-fracture everything. And these were some early tests of that. And yeah, this is all instancer, so no RBD procedural, not raw geometry. Okay. So this is a little bit deeper how it works. So basically you take one type of asset, take one of these, put it to 0. And then I was also obsessed how to fracture it based on curvature. So I used find shortest path to get these lines based on the curvature from one plane, from one projection. And yeah, the trick here was to extend these lines all the way to the edges of the box. And if you combine that with like regular cutter plane setup, this is what you get for primary fracture. And then we have some secondary fractures, and that would be one of these fractured. And then we had 4 of these in this case. So yeah, I did the pre-fracturing of all 4 of them. And then I had for loop to generate these, let's say, RBD proxies. In this case, we used spheres. So that was running through the tops. Okay, and also, so this is the part, it's a bit confusing, but I'm trying to put them back into place and to find out which one of these pieces are intersecting with the others. And these red zones are intersection zones. So eventually what I get is I get these fractured pieces separated. So these are non-intersecting ones and these are intersecting ones. And for these, I can just do what I shown in this like simple explanation. So basically I can fracture them based on like basically turn them into VDB and fracture them. This trick with like fracturing a box and not actual geometry is really efficient. And in the end, this is my RBD geometry. And I simulate that and get a bunch of RBD points. And with these points, I can actually take these fractured instance pieces and transform pieces them, and get my final point cloud. And this final point cloud has information which asset is used where and which fracture piece is used where. So in Solaris, these prototypes loaded. It takes some time for scene to refresh. And when you plug that into Instancer, basically these 4 prototypes get scattered all around. So this is how it looks in Karma, and like memory usage and startup time was really fast for this. Okay, and this was the final result of the scene that I shown you. It's not spectacular RBD simulation. Okay, so eventually I abandoned this approach because nobody could understand how to use it. Okay, so I was running out of time, so there was lecture that I held this September on Houdini Horizon HIVE, and this is the part of this lecture. So before RBD procedural, I made this placement shader that would transform pieces in shader, in Vex shader. Then I used the approach from Luca Scheller, the guy who wrote USD Survival Guide. with skeletal meshes, and this is the performance, and this is RBD procedural. So Luca's thing is a bit faster than RBD procedural, but at this point we were using Houdini 20, and RBD procedural was like in the state that's usable. Okay, and this was one of the first tests of that. Okay. So the only thing was, okay, how should we fuse this geometry? How we should boolean it? And anyone who used booleans knows about this. Yeah. So this is nightmare. Yeah. So I know a guy who has a Python script that basically takes this and run it over, like runs clean and some other SOPs to basically try to fix this. Okay, so I decided to try to merge everything into VDB. So for this final piece, I used TOPS and did it in several steps. But if you merge it into VDB, you see that you don't have these problems with like inside faces. And in convert VDB to polygons, there is this second input that I wasn't aware of it. So basically, if you plug something into second input, all of your attributes get transferred from geometry. So these are paths that are transferred from geometry. So if you go back to Solaris, you get your whole structure back together. So this was like the main thing that allowed me to use VDBs here. And also, you know, if you have different pieces that are converted to VDB, if you don't use this second input, you will get these like blobs in places where cutting lines occur. So I have a slide for that. Okay. Yeah, so we use this VDB fracture node thanks to Hristo Vele, who did a really great tutorial about that. So VDB fracture in this case took around 5 minutes, and that's not too bad, but the main problem with VDB fracture node is that it creates this kind of junk, and you have to manage this kind of junk. And after the project, I created my own VDB fracture. It doesn't use that node at all, and it doesn't create junk. And in this case, it's under 2 minutes, so almost it's more than 2 times faster. And here is with cutter geometries. So here with VDB fracture is 7 minutes. And yeah, you get your geometry and you get a lot of junk. So with cutter planes, you get like enormous amount of junk. And this is with my solution. So in this case, it's only 2 minutes faster than VDB fracture, but it's very, very clean. And yeah, if anyone is interested, I can share later what I did. Okay, and then there is the best RBD sim on FMX this year. Yeah, so you create some convex hulls and do your simulation, and then yeah, I want to put this into Solaris. So nowadays in 20.5, you have to create attribute that's called piece value. Basically, its name on your mesh, and on your points, you have to have the whole path to geometry, and then this piece value, then this name joined together. So this is on geometry. So you can see that there is piece name attribute. That's name, and that gets written to primvar. While on points you have an attribute that is path plus name, and this is also called piece name. And in Solaris, you import your geometry, your fracture geometry, and you see that there is this piece name primvar. Okay, and then if you apply RBD procedural to it, and yeah, so basically you're taking your your points. I don't know what I'm showing. Yeah. Okay. Yeah, you are taking your points and applying them to RBD procedural, and then you use Houdini preview procedural to see it. And on farm, Houdini preview procedural is run automatically. And you don't want to write thing from preview procedural, because you are writing your baked out geometry. You want to write your like tidy cache, only points, and this is the result of that. So yeah, okay, let me go back. So this is okay, but our asset has really complex structure. So the main problem now is how to marry this like complex asset structure that has a lot of paths and this RBD procedural thing. And first challenge there was to convert this to polygons efficiently. So what I did, I converted this piece by piece. So this is one piece. And I, for the second input of convert to VDB, I need to take USD primitives that are affecting this small piece. So this is the trick I use. I convert it to a bunch of reinforced boxes and detect which boxes are intersecting with our bounding box. And then I get the names of USD primitives that are affecting this bounding box, and then I unpack them. So I don't want to unpack everything all the time. And this subnet is just a bunch of knives. It's 9 knife tools, which just cut these USD geometries. Okay. Yeah, and here I use that. So there is like, they have their own paths, and I want to transfer these paths to our VDB. And you see here, when I convert with that input activated, this is without, this is with. So that secondary input in convert VDB to polygons creates these like hard fracture edges, which is what we need. Okay. And then, yeah, when we import this mesh into LOPS, we get, okay, this is still in SOPs, but there are some parts that don't have paths, and I wanted to see what are these. These are your interior faces. So what you can do with this, you can give that some path, and basically that could be totally separate geometry on which you apply your like displacement shaders, tri-planar or whatever. And this is visualization of the paths. And now when we import that in Solaris, everything is in proper structure, and we have this. So this is this that I hidden are originals, and inside is inside faces. Okay, so next step is very complicated. This is the main problem: how to marry these two. So RBD points need to have full path on the pieces they drive, and that means that single RBD piece should transform multiple of these. So, for example, on the right, you see that single RBD point should transform both these red and blue primitives. So what I figured out is basically you can just duplicate your RBD points and just change the first part of the which is path, and the second part will be the same name piece. And yeah, I have video for this, but it's very confusing. So what I do on RBD points is I create an array of paths that this RBD point should drive. So here it's one path, but here, for example, there is multiple paths that are tied to that point. So I have this like awesome point replicator wrangle, which just creates a bunch of new points. So we had 1,000 points, and now we have 1,004 40 points. And when we plug that into RBD procedural, it takes some time, and this is sped up. So it takes like 30 seconds or something like that. Yeah, so if you use in RBD procedural, if you use this mode of creating prim, it will be slow as hell, because what Houdini will try, it will try to put all of your points of whole time range into one primitive. So what you want to do, yeah, so here I set it up only to load one frame, and it took some time. So everything is in this points primitive. So if you change the mode, so you load BGO sequence directly into RBD procedural, everything should be running very fast. So here I just correct frame range. So this like BGO of your points is being written in one attribute on geometry. So Houdini procedural knows which BGO cache to use. Okay, and this is the same awesome RBD simulation, but now with shaders and everything that asset has, basically sublayered with our RBD simulation. And that's the goal. So you really don't want to mess with the structure of the asset. So if asset people give you some structure, you want to retain the same structure and to give that to lighters. And yeah, this is the thing about sublayering. So your RBD sim should be sublayered over the asset. And here I have layer break. So whatever is above layer break doesn't get written to my effects USD. And the trick about instanceable prims, they have to be converted to non-instanceable prims. And transforms have to be reset on RBD prims. Thanks to Luca, there is snippet on his USD survival guide. And then you see that there is rope with which you write your RBD thing. And of course, then you can also apply some materials to inside faces, and that's all that we did on the project. Okay. Okay, we are good with time. Okay, cool. Yeah, these are some early tests that we did for project for these lava shots. Unfortunately, it's not MPM, it's flip. Yeah, so I was playing with emitting divergence directly into flip and this like melt setup. Okay. And yeah, I promised to you more about instanceable references. So if you try to do anything with it, with instanceable reference, you cannot move its children. You cannot, here you see what is the original material, but let's say you want to override some material for like lighting purposes. You can't do that. And anyone who tried to apply materials on crowd in Solaris knows how painful that is. Yeah, so when you reference anything in Houdini, there is this inherit paths metadata thing, which tells what is the class primitive for that's made for that asset. So you can basically mimic the structure of that. So you create a bunch of primitives in that class primitive. So these are like a bunch of empty groups. But if you apply material to these empty groups, your material get applied. And if you have multiple of these, multiple of instanceable references in your scene, you'll see that this material override gets applied to all of them. And you can also use Python script for that. So your class primitives get made automatically, and then you can do with them whatever you want. So in this case, I'm assigning yellow material to them. Yeah, so this thing, so here you see up above is this like class structure which mimics structure of our assets. And in the scene, we have 4 assets referenced, but there are actually 3 types of 3 unique assets. So we have in class, we have 3 asset structures. Okay. And that should be it. Yeah, so my special thanks goes to Luca for his USD survival guide, to Artyom Smirnov, who helped me with RBD stuff, to Jay Silin, who gave us opportunity to work on this project, to Igor Žanić, Hristo Velev, and Fiona Wong. Okay, and that should be it. Any questions?
I love the idea of assessing objectively these multiple ways of doing the same thing in Houdini and seeing which one's the best. Really awesome. Question?
Hi, thank you. Wonderful presentation. My question is that would you please share your idea about your custom RBD fracture, or is it kind of secret?
The idea is basically you have your fracture pieces, you convert them to VDB, and then if they're on the edge of geometry, you combine them with like whole shell of the object. So you subtract, intersect it with actual object. But if they're inside, you don't have to do anything. So if they are deep inside the object, you just convert them to polygons, and that's it. Sorry, you just leave them as is because it's VDB. I might share it. It's not too complicated. And if they are outside, you don't do anything with them. You just keep them. So basically, the whole idea about, and you can do it with geometry as well, like Voronoi fracture on complex geometry can be very slow. So if you do it on the box that is around your geometry with the same points, it's much faster. And then the only issue is how to get rid of these like outer shells of outer Voronoi shells and cut them with your shell. So that's the idea.
Other questions?
Anyone else?
Yeah. All the way at the back. This room is bigger.
Yeah, thank you. Thank you. I want to ask, after cutting the fracture inside, the inside pieces, they got new polygons.
Yeah.
And is this polygon with UV, so you can map some texture on it?
In our case, we did like automatic UV on it, but eventually on some shots we use this like hex stripe planar. Mm-hmm. So you just have to give it a rest, and it will work.
Okay, thank you.
Other questions?
I think the like your fracturing approach with the like find shortest path and then connecting the lines over the geo looked very interesting. Could you say a bit more about that?
Yeah, I'm developing it more. Like my initial idea was to detect curvature on 3D geometry, and then like so for example, you want to draw curve around your geometry and use that for cutting of your geometry. In the end, I did it in 2D. So I did it in some cases from one plane if the asset is very flat, but in some cases I use 2 planes. And basically what you do is you detect curvature, you scatter some points in these zones, and you just do find shortest path from that point to the edge of the box that's surrounding it. There is some cleanup that you need to do, like some dead ends, like paths that don't connect to anything. But this idea, like it's still bothering me, like how to do it. But I might have another lecture on that.
Well, thank you.
Any other? Going once, going twice. Excellent. Well, thanks very much, Bogdan. Great work.
Thank you.